Hi class, this recording is going to be a little bit shorter compared to most of our recordings. There's not as much material or content that will be going on this recording. For this recording, we're going to be focusing on the refractory period. And when we think of that refractory period, I want you to think of a period of time, a few milliseconds after the action potential or towards the end of the action potential, when it's hard or impossible to initiate another action potential. So as we think of that refractory period, it resists. This is a period of time where there's a resistance to new action potentials being generated. And there's two primary phases. There's the absolute refractory period and the relative refractory period. During this absolute period of time, where we're having sodium rush in, potassium rush out, and the cell membrane is starting to become hyperpolarized. There is no stimulus of any strength, regardless of how powerful that stimulus is. We cannot trigger a brand new action potential. Officially, our absolute refractory period is going to be active as long as sodium voltage gated channels are open. Pragmatically speaking, though, if we have potassium voltage gated channels open here, it's almost high near impossible or nigh near impossible to initiate a new action potential. So, pragmatically speaking, what does this absolute refractory period mean? This means that there's an upper threshold in the number of frequencies of action potentials that can be initiated over a period of time. There's a max limit due to this absolute refractory period. We also have a relative refractory period. And as we look at the relative refractory period, this is a period of time when it's very difficult to initiate a new action potential, but we can initiate a new signal if we have a very strong and especially strong stimulus. During this period of time, with the absolute refractory period, some of the potassium voltage gated channels are still going to be open. Generally speaking, they tend to close right here, but there's still a few lingering potassium voltage gated channels that are going to be open. And as a rule of thumb, when we think of the relative refractory period, I want to think of it as the period of hyperpolarization. Now, let's think about this in terms of voltages. To initiate an action potential, I'm going to switch to blue here, maybe make our cursor a little bit thinner. So to initiate an action potential, we're at resting membrane potential of negative 70 millivolts. And we have some local potential, raises up to threshold. And once we hit that point right there, that negative 55 millivolts, we initiate the action potential. Now, if we're hyperpolarized, instead of having to increase the voltage 15 millivolts to reach threshold, I now need to increase the voltage, we'll say 20 millivolts to reach threshold. So we now need a stronger or a more pronounced change in voltage to initiate the action potential, which is another way of saying that we need to have a much stronger stimulus to initiate the action potential than we would have normally had we been at the negative 70 millivolts of resting membrane potential. And that's all we have for this recording. If you have any questions, please feel free to post them on the class discussion board or feel free to shoot me an email. And as always,